In this question, we are given an expression 1 over 3 minus 2x raised to the power of 2/3, and we have to expand it up to first 4 terms and also find the value of x for which the given expansion will be valid. So let us begin by first simplifying the given expression. What we can do, we can take the binomial expression which is in the denominator to the numerator, and that would become 3 minus twice x whole raised to the power negative 2/3. Now we are going to factor out 3 such that we have 1 in one of the term and the other term will have x in the numerator, assuming that we are going to expand in increasing powers of x. So when we factor out 3, we have 3 raised to the power negative 2/3 times 1 minus 2/3 of x whole raised to the power negative 2 over 3. So let us now expand. So this will give us 3 raised to the power of negative 2 over 3 times the first term, which is 1, plus n. So our n value is negative 2 over 3 times x. So x here is negative 2/3 of x plus n, which is negative 2/3 times n minus 1 divided by 2 factorial times negative 2/3 of x whole square plus negative 2/3 times negative 2/3 minus 1 times negative 2/3 minus 2 divided by 3 factorial times negative 2/3 x raised to the power of 3 plus the remaining terms. Now we simplify the values, and that would give us 3 raised to the power negative 2/3 times 1. So we have a negative multiplied to a negative, so we'll have positive, so that would be 4 divided by 9x plus negative 2/3 times negative 5/3 divided by 2 factorial will be 2 times negative 2 squared will be 4, x squared will be 4x squared divided by 3 squared, which is 9, plus negative 2/3 times negative 2/3 minus 1 will give us negative 5/3 times negative 8/3 divided by 3 factorial, which is simply 6, times negative 2 cubed will be negative 8 and x cubed divided by 3 cubed, which is going to be 27, plus the remaining terms. So now we further simplify, and that gives us 3 raised to the power of negative 2/3 plus times 1 plus 4 over 9 x. Then we use a calculator to calculate the constant coefficient, and that would give us 20 over 81. Wait, it's not going to give us 20 over 81. 20 over 81 x squared. And this particular term, the fourth term, will be equals to 320 divided by 2187 times x raised to the power of 3 and the remaining terms. Since we are asked to find out the first 4 terms, so the first 4 terms will be given by 3, so we can multiply it, but I'm leaving it the way it is. So we have the 4 terms. Now what we're going to have to do, we have to find the value of x for which the given expansion will be valid. So we will consider this particular part, which is 1 minus 2/3 of x. So we'll consider 1 minus 2/3 of x, and for this binomial, it has to satisfy the condition that the absolute value of the negative 2/3 of x must be less than 1. So this will give us 2/3 of x. The absolute value of x is less than 1. Multiply both sides by 3/2. So that would give us the absolute value of x is less than 3/2. This is the required condition, or we can say that x belongs to negative 3/2, comma 3/2. So next, move on to the next question. It's similar to the previous one. So let us begin by simplifying the given expression. So we can rewrite the expression in the denominator as 5 minus 4x squared whole raised to the power half. And then we take the entire expression to the numerator, and that will give us 5 minus 4x squared whole raised to the power of negative half. Now we factor out 5. That would give us 5 raised to the power negative half times 1 minus 4/5 x squared raised to the power of half. Again, we are going to expand in increasing powers of x, so that's why we took the 5 as the common factor. So let us expand using the binomial theorem. So that would give us 5 raised to the power of negative half times 1 plus n, which is half, negative half, times x, which is negative 4/5 x squared plus negative half times negative half minus 1 divided by 2 factorial times negative 4/5 x squared raised to the power of 2 plus negative half times negative half minus 1 times negative half minus 2 divided by 3 factorial times negative 4/5 x squared raised to the power of 3 plus the remaining terms. So we can write this as 1/5 raised to the power of half times 1 plus we'll go ahead and use a calculator, and that should give us 2/5 x squared let's use a calculator to find this value, and that would be positive 6/25 times x squared whole squared will give us x raised to the power of 4 plus 4/25 times x raised to the power of 6 plus the remaining terms. So this is the expansion, and we have the 4 terms. Now we have to find out the value of x for which the given expression is going to be valid. The given expansion will be valid, so we'll pick up this one, 1 minus 4/5 x squared, and we use the condition. So we have 1 minus 4/5 of x squared. So in this binomial, we need to have the absolute value of x squared to be less than 1. So this gives us 4/5 of the absolute value of x squared, which is simply x squared, is less than 1. Multiplying both sides by 5/4, then we get 5/4. So x squared x minus of 5 over 4 less than 0. X squared minus, now 5 over 4 can be rewritten as square root of 5 divided by 2 whole squared less than 0. And then we can apply the identity, a squared minus b squared equals to a minus b times a plus b. So we'll have x minus square root of 5 over 2 times x plus square root of 5 over 2 is less than 0. So this gives us the range of values that x will assume, that will have between negative 5, negative square root of 5 over 2 and square root of 5 over 2. Or we can say that x belongs to negative square root of 5 over 2 to positive square root of 5 over 2. Or we can say that the absolute value of x is less than square root of 5 over 2. Let's move on to the next question. So we have to expand 1 over 2 minus 3x whole cube. So let's simplify this. So we take it to the numerator, so we get 2 minus thrice x raised to the power of 3. Then we factor out 2, so we have 2 cube times 1 minus 3 over 2 times x raised to the power of 3. So 2 cube is simply 8, and then we expand using, this is negative 3, my mistake, so this is negative 3, the index, since we have taken it to the numerator, so this will be 8 times 1 plus negative 3 times negative 3 over 2 x plus negative 3 times negative 3, negative 1 will give us a negative 4 divided by 2 factorial times negative 3 over 2 x whole squared plus negative 3 times negative 4 times negative 5 divided by 3 factorial times negative 3 over 2 x raised to the power of 3 and the remaining terms, which will be equals to 8 times 1 plus 9 over 2x plus, so we have 3 times 4 is 12, 12 over 2 will give us 6, 6 times 9, so we can go ahead and use a calculator, and that will give us 27 over 2 x squared, and the fourth term will give us 135 over 4 times x cubed. So we have all the terms. Now we can even go ahead and multiply the 8, so let's do that. So that would be 8 times 1 is 8 times 9 times 4 is 36x plus 108 x squared plus 270 x cubed. So these are the four terms, the first four terms in increasing power of x. Now we have to find out the condition, that is the radius of convergence for x. So we'll consider 1 minus 3 over 2x, and here it requires us to have this condition that the absolute value of negative 3 over 2 times x must be less than 1, which gives us 3 over 2 times the absolute value of x must be less than 1, or you can say that the absolute value of x is going to be less than 2 over 3. Let's move on to the next question. So here we have another expression, 1 minus x squared raised to the power of 7 over 3. So we have to expand it up to the first four terms and then also find the value of x, for which will make the expansion valid. So let us begin. So in this particular question, we see that one of the terms is already 1, so we do not have to factor out anything. We can straight away apply the binomial theorem. So we have 1 plus 7 over 3 times negative x squared plus 7 over 3 times 7 over 3 minus 1 divided by 2 factorial, which I'm writing here as 1 over 2 factorial, times negative x squared raised to the power of 2 plus 7 over 3 times 7 over 3 minus 1 times 7 over 3 minus 2 whole divided by 3 factorial, which is also simply 1 over 3 factorial times minus x squared raised to the power of 3 plus the remaining terms. This would be minus 1 minus 7 over 3 x squared plus, I'll use a calculator and the value will be, we have 14 by 9, x squared whole squared will be x raised to the power of 4, and we have minus 14 over 81 times x raised to the power of 6 and the rest of the terms. So here we have the first 4 terms in increasing power of x. Now we'll find the condition for which condition in the sense like they will find the values of x for which the given expansion will be valid. So we need to have the absolute value of x squared to be less than 1, which is simply x squared less than 1, and the absolute value of x squared is simply x squared, which is less than 1. That gives us x squared minus 1 is less than 0. We apply the identity, we get x minus 1 times x plus 1 is less than 0. So we have x lying between negative 1 and positive 1, or we can say that the absolute value of x is going to be less than positive 1. So this is the condition. Any values lying between negative 1 and 1 is going to make the expansion valid. Let's go to the next question. So here we are provided with an expression 1 over the cube root of 6 minus 3x, and we have to expand it up to the first 4 terms. So let us begin by simplifying the expression. So we can write it as 1 over 6 minus 3x raised to the power 1 over 3, and then take it to the numerator. That gives us 6 minus twice of x raised to the power of negative 1/3. Now we're going to factor out 6, so we'll have 6 raised to the power of negative 1/3 times 1 minus 3 over 6 times x raised to the power of negative 1/3. So this is simply 6 raised to the power of 1/3 times 1 minus x over 2 raised to the power of negative 1/3. So let us apply the binomial theorem. So we have 6 raised to the power of negative 1/3 times 1 plus n, which is negative 1/3, times x, which is negative x over 2, plus negative 1/3 times negative 1/3 minus 1 divided by 2 factorial times negative x over 2 whole squared, plus negative 1/3 times negative 1/3 minus 1 times negative 1/3 minus 2 divided by 3 factorial times negative x over 2 raised to the power of 3 plus the remaining terms. Further simplification gives us 1 over 6 raised to the power of 1/3 times 1 plus x over 6. So I'm going to use a calculator, and that value is going to be 1 over 18 times x squared, and the fourth term will be 7 over 324 times x cubed plus the remaining terms. So here we have the first 4 terms, so the expanded value of the given expression. Now we have to find the condition, we have to find the value of x for which this particular expansion will hold. So we consider the binomial 1 minus x over 2, and here we consider the absolute value of negative x over 2 must be less than 1, and that gives us absolute value of x over 2 is less than 1, which implies that the absolute value of x must be less than 2. So all you can say for all values of x, or we can say for all values of x lying between negative 2 and 2, the above expansion, binomial expansion, will be valid. Let's move on to the next question. In this particular question, we are given a squared minus ax raised to the power negative 3 over 10. So let us first simplify the given expression. So what we do first is we begin by factoring out a squared. So we have a squared raised to the power negative 3 over 10 times 1 minus a over a squared times x raised to the power negative 3 over 10. This will be equals to a times a raised to the power. So we can multiply the exponent, so that would simply give us negative 3 over 5 times 1 minus 1 over a times x raised to the power of negative 3 over 10. So let us apply the binomial theorem. So we have a raised to the power of negative 3/5 times 1 plus negative 3 over 10 times negative x over a plus negative 3/10 times negative 3/10 minus 1 divided by 2 factorial times negative x over a whole squared plus negative 3 over 10 times negative 3/10 minus 1 times negative 3/10 minus 2 divided by 3 factorial times negative x over a cubed plus the remaining terms. So this will be equals to a raised to the power negative 3/5 times 1 plus thrice x over 10a. I'm going to again use a calculator, and that would give us 39 over 200 a squared times x squared plus 299 divided by 2000 a cubed times x cubed. So we have all the 4 terms that were required. So the given expression has been expanded to the first 4 terms. Now we find out the condition. So our condition requires that the absolute value of negative x over a must be less than 1, which implies that the absolute value of a upon the absolute value of a must be less than 1, which implies that the absolute value of a must be less than the absolute value of a. So this is the range for the value of x, so that, or you can say that x must lie between negative a and positive a. So for all values lying in the particular range, the given expansion will hold. Let's move on to the next question. So we have 1 over the cube root of 1 minus x squared. So let us simplify this first. So we can write it as 1 minus x squared raised to the power of negative 1/3. Now the first term is already 1, so we do not have to factor out anything. So let's straight away apply the binomial theorem. So we have 1 plus negative 1/3 times negative x squared plus negative 1/3 times negative 1/3 minus 1 divided by 2 factorial times negative x squared whole square plus negative 1/3 times negative 1/3 minus 1 times negative 1/3 minus 2 divided by 3 factorial times negative x squared raised to the power of 3 and the remaining terms. So this would give us finally 1 plus 1/3 of x squared plus, it's going to be plus 2 over 9 x raised to the power 4. I have already calculated these values using a calculator, you can verify it, plus 14 over 81 times x raised to the power 6 plus the remaining terms. So these are the first 4 terms for our given binomial expression. For our expression, this is the binomial expression. Now we find out the condition, so that would be negative x squared, the absolute value of negative x squared must be less than 1, which implies that we have absolute value of x squared is less than 1, or we can simply say that x squared is less than 1, which implies x squared minus 1 is less than 0. Then we can do a further simplification by applying the identity x minus 1 times x plus 1 is less than 0. So that means this means x lies between negative 1 and positive 1. So for all values of x lying between negative 1 and positive 1, the expansion will be valid.